Hi, this is Mrs. Rodriguez with another lesson video. Today's lesson video is on the Chapter 3 practice test, okay? Going over the practice test to make sure you understand everything. So, question number 1, simplify the expression. We have 4 squared plus 9 times 2 divided by 6 plus 6 minus 1 in parentheses with an exponent of 2. So this is an order of operations problem. Okay, so I'm going to go ahead, rewrite the problem over here. 4 squared plus 9 times 2 divided by 6 plus 6 minus 1 to the second power. Okay, so remember, in order of operations, you do parentheses first. So the parentheses in this case would be that 6 minus 1. So I'm going to go ahead and just rewrite the other parts of this problem. Okay. Second step is exponents, and we have 2 sets. We have an exponent on the 4 and on the 5, so I'm going to do those next. Remember, 4 squared is 4 times 4, okay? That exponent, that little number, tells you how many times you're multiplying 4 to itself. Just like the 2 on the 5 is telling you that you're going to multiply 2 5s together. So we have 16 plus 9 times 2 divided by 6 plus 25, because 5 times 5 is 25. Now the next step in order of operations is multiplication or division, whichever one happens first from left to right. So remember, it's like reading a story. We go from left to right. So we're going to start at that 16. We're going to ignore the 16 and the addition. But we do have 9 times 2, so that's our first multiplication. So that's going to be 18, and then we have 18 divided by 6 plus 25. So the next one we're going to do is that division. So 16 plus 18 divided by 6 is 3 plus 25. Now I'm going to go ahead and just add from left to right. 16 plus 3 is 19 plus 25, and that is 44, and that's our final answer. Okay, 44. For number 2, find the number that would make the equation true. So here we have negative 27 equals some mystery number times negative 9. So the first thing I need to think about is how many times does 9 go into 27, right? Because 9 times some mystery number equals 27. 27 divided by 9 is 3. So I know that there has to be a 3 here. Now I have to think, okay, now if I want my answer to be negative, remember, this is our answer, and the answer is negative. And the 9 is negative. What sign does the 3 have to have? Is the 3 going to be positive, or is the 3 going to be negative? We have to remember, a positive times a positive equals a positive. A positive times a negative equals a negative. And a negative times a negative equals a positive. All right, so if the answer is negative and the 9 is negative, then that means we're looking at this scenario. And if the 9 is the negative number, that means that 3 has to be positive. So it's going to be a positive 3. Okay? Moving on. Find the number that would make this equation true. So instead of multiplication, here we have addition. Some number, some mystery number plus 4 gave us negative 5. Okay, so that means if I have, or I'm sorry, not negative 5, negative 15. So that means negative 15 minus 4 should give us our answer. And just like with this multiplication problem up here, we did the opposite and we divided, we're going to do the same thing. We're going to take that addition, right, and we're going to do the opposite to find out what that mystery number is. So we're going to subtract 4 from negative 15. So remember, subtracting is just adding the opposite. We're going to change the subtraction to addition, change the sign of the second number to a negative 4, And then you can plainly see that if I have 15 negatives and I add 4 more negatives, that I have a total of negative 19. Okay. Another way you could have done that is draw a number line. You could have drawn a number line and then counted how many spaces forward you would have to go to get negative 15, right? If you subtracted 4 from it. And then number 4, compute the following. 1.8 times 0.032. So this is multiplying decimals. If you remember, the first thing we should do is ignore the decimals and just multiply like normal. So this will be 32 times 18. We're ignoring the decimals. Okay, 8 times 2 is 16. I carry the 1. 8 times 3 is 24, plus 1 is 25. Now I have to do the second number in the problem. Remember, we need the placeholder because that 1 is in the tens place, so I need to start the answer for the 1 in the tens place. 1 times 2 is 2. 1 times 3 is 3. I go ahead and add it together and I get 576. So this is going to equal 576. Now all we have to do is figure out where the decimal goes. So if we look, we're going to count how many numbers are after the decimal for each one. And for 1.8 we have 1. For 0.032 we have 3 numbers after the decimal. And then remember, you add how many place values after the decimal we have total, and that's 4. So that means I'm going to have 4 numbers after my decimal in my answer. So I start all the way at the end on the right side and I go in 4. 1, 2, 3. Oops, I ran out of numbers. So anytime you run out of numbers, that's okay. You just add a 0, 4. And our decimal is going to go there. So our final answer is going to be 0.0576. Okay. For number 5, it says compute the following. Here is a mixed number divided by a whole number. So the first thing we need to remember is how to change a mixed number into an improper fraction. So 4 2/3, remember we multiply the denominator with the whole number and then we add the whole number with the numerator. So it's going to be like this. 3 times 4 plus 2. And the denominator stays the same. So this 3 stays the denominator. Okay? Now, 3 times 4 is 12. 12 plus 2 is 14. So this is going to actually equal 14 over 3. Now, we're still dividing, and we have a mixed number divided by a whole number. Okay, so we changed the mixed number to an improper fraction. Now we need to change that whole number into a fraction so we can go ahead and just divide 2 fractions. So in order to change 7 into a fraction, we just stick a 1 under it. Okay, so it's going to be 14 over 3 divided by 7 over 1. Now we're ready to divide. And remember, when we fractions, what we're actually doing is multiplying by the reciprocal. We are multiplying by the reciprocal. So that means we're actually multiplying 14 divided by 3 times the reciprocal of 7 over 1. And the reciprocal of 7 over 1, we just flip the fraction and we get 1 over 7. Okay? Now, you could just multiply across and you would get 14 over 21. Simplify, both are divided by 7, and you get 2 over 3. Another option is you could have cross-simplified once it became a multiplication problem and gone, okay, well 7 goes into 14 2 times, 7 goes into 7 1 time, and you get 2/3. Either way works, okay? If you want to cross-simplify, go for it. If you don't, you can still get the correct answer. You'll just simplify at the end instead of in the middle. All right, for number 6, compute the following. We have 0.96 divided by 0.3. So this is going to be on dividing decimals. Let's do it. We have 0.96 divided by 0.3. The first thing we need to realize is, or figure out, is which one is our top dog. And our top dog is going to be the first number listed, right? So it's going to be 0.96. So 0.96 is going to go in the house, and 0.3 is going to go outside of the house. Okay, now the next thing we need to do is check to see if we have to move any decimals. And sure enough, we do, because remember, you're not allowed to have the outside number, the divisor, have a decimal in it. If it has one, you have to get rid of it. We don't care about the top dog because you can have a decimal inside the house. Remember, we add decimals when we do long division. We add a decimal to add zeros if we keep getting remainders. So in the house is okay. Outside of the house, not okay. So in order to make 0.3 into a whole number, I'm going to have to move the decimal over to the end, one place. I can do that if I also do the same thing inside the house. So I'm going to take the decimal inside the house and also move it one place. Okay, and that's going to give me 3 into 9.6. Now I'm ready to divide. Remember, wherever your decimal is, it's going to align with your final answer. Okay. And let's go ahead and get started. 3 goes into 9 3 times. 3 times 9, 3 is 9. So we subtract. We drop down the 6. 3 goes into 6 2 times. 2 times 3 is 6. We subtract, no remainder, and that means our answer is going to be 3.2. That's going to be our answer. For number 7, how much tax you pay when you buy an item depends on the state you live in. The tax rate in California is 7.25%. Convert this percent to a decimal. So we have to remember how to make a percent into a decimal. And to do that, you can either remember that you're dividing by 100, or so you could divide by 100, or you could remember that by dividing by 100, what you're really doing is moving the decimal place over to the left 2 spaces. And we don't have a number in front of the 7, and that's okay because we just add zeros whenever we're missing numbers, and the decimal will go here. So our answer is actually going to be 0.0725. Remember, yes, this has a decimal, but that's still a percent, okay? It's still a percent. So like I said, you can divide your percent by 100, or just remember to move the decimal over 2 spaces to the left. If we were going from a decimal to a percent, the decimal will be moved 2 places to the right, because instead of dividing by 100, you would be multiplying by 100. Okay, moving on. A spinner is divided into 6 equal colored sections: blue, yellow, orange, purple, green, and red. What is the probability of spinning black? Okay, so inside our spinner, we have blue, yellow, orange, purple, green, and red. They want to know what's the probability of spinning black. Okay, well, there's no black on the spinner. If it's not on the spinner, then there's no probability of getting it. So the answer is going to be 0. There's 0 probability. There's no black on the spinner. So you can't do anything with it. All right. 9. Simplify the following: -6 plus -3 plus -2 plus 9. All right, so this is adding integers, right? Positive and negative numbers. And the key with this one is I would just take it one step at a time, okay? So we have -6 plus -3. I'm just rewriting the problem, plus -2 plus 9. So yeah, I would just take it one step at a time. It's addition, so order of operations says that you just start adding from left to right. So -6 plus -3. If I have 6 negatives and I add 3 more negatives to it, that's going to give me -9. Remember, you could also do this on a number line. Okay, if this is my -6, 7, 8, 9, 10. Okay, if I started at -6 and I'm adding 3 more negatives, remember negatives go towards the left, then it would be 1, 2, 3, and you would get -9. So you could be using number lines to solve these too. All right, now that we have that part done, now we're going to go ahead and bring down, that -2, okay? And we're going to add these two together now. And once again, we have 9 negatives. We're adding 2 more negatives. So if I were to keep going 2 more spaces to the right, let me see if I can add another negative in there. Okay, so now I'm at -9 and I go 2 more spaces. Let me change colors. Let's do black. Now if I'm at -9 and I go 2 more spaces to the left, 1, 2, I end up at -11. So -9 plus 2 more negatives gives us -11. And now we're ready to add that last number, the +9. So we're just dropping down this +9, and now we're going to add these two together. So once again, I'm going to draw a new number line because that one's getting a little too squished. Okay, so I have -11 and I'm adding 9 positives to it. So if I'm adding 9 positives, I know 9 positives go towards the right because positives are on the right-hand side of the 0. So they go this way. All right, I'm going to count 9 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8, and we get -2. Now for this one, remember there's always more than one way to do everything, so you could have done the integer tiles too. I'll show you for the first one, the -6 and the -3. For the -6 and the -3, you could have done 1, 2, 3, 4, 5, 6 negatives. We're adding 1, 2, 3 to them. How many total negatives do we have? -9, right? Now we're adding 2 more. So actually, let me go ahead and erase the circle. So we have -9. Now we're going to add 2 more. So plus -2. And if we add 2 more, now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now we have -11. And then if we add the +9, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. If you'll remember, 1 positive and 1 negative cancel each other out. So I'm going to go ahead and make my pairs, my 0 pairs, and cancel them out and see what I have left. Okay, so this one will go with this one will go with this one, and this one will go with this one, and I'm left with exactly -2. So I'm left with -2. Let me go ahead and highlight it in green. That's what I have left. So -11 plus 9 positives gives us -2. Remember, there's always more than one way to do everything. You just got to figure out what works for you. Okay? All right, and then last but not least, we have problem number 10, and it looks like a graphing problem. So 10 says, Jerome runs a bakery with his husband, Alec. Jerome has invented the new Mathberry chocolate cake, and word is getting around. He's created a list of how many people are liking the cake so that they can decide if they should keep it on the menu or not. Positive numbers are a number of people who like the cake, and negative numbers are people who dislike the cake. Graph the points. Okay, so we're just graphing points, guys. This is just like when you did the mystery graph. So when we're plotting points, remember, your x-axis is always the one that goes from left to right. Your y-axis is the one that always goes up and down, okay? Now, when you're given data like this, remember the first number is always your x, the second number is your y. And a table like this, if you can imagine it, what it actually is here's your points, right? This is normally how you're given points, but this is just in a table form. But if this makes you feel better to think of it as points, because they are points, you can always rewrite them that way. So our first number is x, our second number is y. So let's do this. I'm going to pick pink, and we have day 1 is -4. So 1 and -4 is going to be right here. 2 is 2 and 2. So this was day 1. This is day 2. So day 1 looked a little rough. 4 people disliked it. But day 2, we got a couple of people liking it. Day 3 is -6. That's not good. See here, I'll number them here too, so you can see which ones I'm labeling and follow along. Okay, so day 4 is 4 and 8. Day 5 is 5 and -5. Day 6 is 6 and 9. And day 7 is 7 and 10. So it looks like I'm actually going to have to move that. So here is day 7. So this is number 7, and this one was number 6. Okay, so those are the points graphed. Now, I don't know, it looked like they had a little bit of a rough start with the recipe on some of the days, but it looks like overall people ended up liking the cake, so they should keep it on the menu. Okay, so on that note, that was the 10th problem. So that is the end of the practice test. Remember, the real test is just gonna be just like the practice test. I just changed the names and the numbers. So please study the practice test. And as always, if you have any questions or need additional assistance, feel free to make an appointment with me for office hours. Hope you have a great day. Bye.